Lovely. Thanks ever so much for joining us from all over, wherever you are. It's always fascinating when I see where people are from. So please say hi in the chat. Let me know where you're from, because it's lovely to get that feel for who's in the room. So my aim for this session is to have a look at that move from blocks to textual-based programming, how to switch the view, what can we edit, where can we start, look at having to use the debug mode so that we can see that viewing the code and the code steps, using tutorials so we can use that simulator, using commenting, moving to MicroPython, and then using Classroom and some strategies there for that textual-based programming. So I'm going to jump straight into this and start by looking at that switch and how to get from block-based into the textual-based programming. So Makecode obviously allows students to see that switch very easily, and we can pick things out that we can actually start changing and editing. Now I am going to make the jump and keep switching my screen in between looking at the actual platform. So from here, I'm just going to jump straight over onto my first tab here. So we've got that program here, something very basic, obviously, just to start off with. But when they're starting to think about how can we actually look at that in Python, we can actually go straight up the top and flick over to look at the Python view. And what we can do then is start to look at, well, what could we possibly change? And the nice things to start with is really to try and understand what that individual lines of code do. But obviously, the first thing to think about is where that image is displayed. Now, the heart is what is going to be displayed on the screen of the display of the microbit, but we can change that very easily to another symbol. So let's go for sad. And what happens over here now is that we just get that play. So if I press play just to move that program over onto the simulator, I can now simulate that there. And the nice thing I can do is go back to my blocks, and it has changed my blocks as well. So I've got that scaffolding there of not being too sure whether I'm changing things right, but can go back and look at the blocks and get a bit of reassurance, but also going backwards and forwards to actually see what it's like. Could I add in another little bit of code underneath? What would happen if I put something else in? What would it look like on the actual within Python? Could I actually then add another line of code underneath and building it up slowly, checking it back with that block-based? And again, it's that slow transition through to using the textual-based, but actually like by making those small changes. I'm just going to go back to my slides, and I've got, obviously here is all the different images that you can change within the Python side of things. So that's and I've got a list of all these, and I have got that to share with you, but all the potential options that you can change, because it's quite nice to have that in front of them if they know what they can change right from the word go. So the next thing is using the debug mode to really step through the code, because it's really important to know what line of code is actually being run as you are running the program. One in blocks, but then when you go into the textual base, looking at the Python, well, which line is being executed at which time? And again, that can be done nicely within the debug mode. So I'm just going to go back over and just go to tab 2. I've got this one set up. By clicking on the debug mode over here, what I can do is I can click the A button to run my program. But if I click the snail button here, which is slow-mo, what it'll do is as I press the A button, it will slowly run through that program so I can see what it's doing step by step. If I turn that debug off and go through onto the Python, it runs slightly different. Again, if I click debug, and I'm just going to click slow, press the A button, and it's started to run through, and you can see as it's going through the steps that it's running. So again, it's that being able to actually see which line of code is being run at which point, to be able to then see and work out which block potentially goes with it, but also start to understand what each line of code is doing. And I think it's really key for when students are learning how to use textual-based programming, is that slow build-up of what does each line of code do. And then that allows you to trace that algorithm, trace the program, and work your way through it. Let's go back to my slides. And again, using that within loops can actually help to understand what that is as well. Because obviously when you start looking at the block-based, you get the repeat 4 times. That's the repeat block comes up loads within block-based. Obviously when we start moving to Python, that's a for loop. So seeing the difference and again seeing how that works, that it works in the same way, is easy to do within the with the debug. So again, we've got that program set up here. If I click onto the debug with the snail, and I can see, and the nice thing here is it actually shows within the index how many times the loop has run. So we've gone through it once, and it will run through again, and it runs through, and then increases it here. So I can see that loop working. The same if I go on to the Python. I'm just going to go on to there. Again, click on the snail. And you can see that it's working through. And again, it's going to tell me here when it's worked through each of those iterations. So again, the students are able to see when each loop has been run, making it quite powerful for them to actually understand how a loop works and how many times it's going to run and how the program actually remembers how many times it's running by using a variable. So I think that one is really interesting to do. And I'll just go back to my slides. And the one thing as well is obviously we know that when we start looking at when we go into just using Python, we don't have the simulator anymore for the microbit. The nice thing about obviously when we start looking in Makecode and doing this transition and using the tutorials there is that we do have the simulator there to help us with that first steps into looking at the textual based programming. So if I just move back over, we've got when you get the tutorials up, it gives you that line of code, but you've got the simulator over here to allow us to actually build that up. Now, obviously, the other thing that I quite like is you can't copy and paste the code here. So they are actually forced to write it out. Now, it is slightly different when you move into actual oh, I've got caps lock on. Sorry, I do apologise. When you move over into using pure Python and MicroPython with the Microbit, it is a slightly different syntax than you see within this split view and using it within Makecode. But it is about making that start, about starting to think about how it works, how it looks, looking at the syntax, picking up bits of how the whole system is structured. So obviously there we've got that first bit. I've added it in. I've finished that step. So it's simulating it. Because if you jump straight into using MicroPython within their platform with the Python, you haven't got that simulator and you're losing that little bit of a step that they need to help them understand what the blocks and the text is doing together. And going backwards and forwards is really is needed within that transitional stage. So having this here and the tutorials as well are great. So you've got that platform within Makecode where you can split the view really easily, the tutorials that allow you to build up and practice typing in the code as a next step from changing a few bits within the code. So that's a really good one to use as well. The other thing that I think is really important as well is not just the use of the programming language, is the actual commenting. Now, commenting is so important, and I think it's something that's underestimated within the education, that it needs to be done. It is an industry standard expectation. They are expected to comment within their code if they become a programmer. They're not 90% of the time, they may not be working on their own in a program. They'll be working with others. Or they may be working on something on a longer period of time. So being able to comment in the code helps them to understand what the code's doing, but also helps you to understand what their understanding of the code is, where there are gaps in knowledge, any misconceptions. And the nice thing that you've got is obviously is that you can pick it up in both sides of things. So again, if I just go back over onto an example, I've put a couple of comments on here. And obviously within the block-based code, I'm just going to minimize those for a second. So straight away I can see on this, I'm just going to enlarge it a second so you can see it a little bit clearer. I can see that there's a comment already added onto that block by looking here, and obviously I can click on that to actually expand that out. If I want to add something on, so if I want to right click on this block and I want to add a comment, I can add something on. This will display a large diamond, which was a real one, but there we go. And that adds it in there. So we've added it in. If I flick onto the Python, switch onto the Python view, we can see those lines of comments in here as well. And that is the hashtag that defines what the comment is. And students understand then that a comment is actually looked over, that it's not a line of code. It's actually something that the program knows to actually jump over that. But I can add that in here as well. So if I wanted to add in another little bit here, so I might at the end of here, I'm just going to put a hashtag. This is the A button. I'm adding that in within the Python view. And again, if I go back to blocks, it's going to add that in here as well. So I think I added that on I think I've already got one on there. So it's put it underneath. So it might be on the second one. No, I think it's only one that's viewed on there. So I think I've put it where there already is one. So let me just pull that one back. And I'm going to put it somewhere where there isn't one. This will delay for image. And if I go back, hopefully that should then appear. Here we go, onto this one here. And this image will delay before the next image. So by adding in those little bits of commenting, again, will help with that transition of moving through. They can see where the blocks are. They can see where the lines of code are. And actually can see, then help with that transition of learning what the program is doing, help with showing that understanding and moving through. So then moving to MicroPython, because obviously that's in Makecode. We've started looking at Makecode. We've looked at how to change certain things. And then it's kind of making that jump into the new platform where the programming syntax is slightly different. And I think that's really important if you do it this way, that the students are going to suddenly go, hang on, we used a different way of writing how to display an image in Makecode. It's a different platform. So because the Makecode uses a simulator, it is a different syntax. So this is purely using Python within this environment. So the other aspect is that it always comes up with that while true, again, giving them that understanding of why is it always while true on there. And that's kind of saying the same as, well, when started in Makecode. So you get that default program. I will share the link to that. I've got a Microbit Python Get Started guide that can be used, which shows all the bits that can be changed and taken some of the code off the Microbit website to kind of put in a double-sided sheet that students can. But yes, it is different. And that is something to be aware of, because if I just go back a slide, if you look here on, you've got basic.show icon names.diamond. If I go on to the next one, it's display.show image.heart. So some things are slightly the same. The fact that the syntax has to be in capitals, the word for the image is exactly the same. It has to be in capitals, but the actual line of code is different. And that's something to be aware of if you do make that change, obviously, as you're moving through. So that's why it's important not to stay in Makecode fully, but use it as a transition. Use it as, let's have a look at that. Let's change some of the words. What can we change there? What does each line do? But then moving over into here, and then you can kind of see that the syntax in full. So then it's kind of like, well, how could we use it? How can we actually start them to think about what's in that they're viewing and the programs that they're looking at to help them understand with that transition again? So start with sequence. Then you can take out that while true, and we can just have a program that just runs right from the word go and just a simple step through. So this here is just as an example. So this is an example of using prim, which is one of the pedagogies: predict, run, investigate, modify, and make. So this is like, so starting, you would have a program that says, predict what this is going to happen. What's going to happen if I run this program here? So before they get it in front of them, he's showing that program to them. What will happen when this will run? And they would look at it, and it's about reading through that program, understand what's going to happen when they download it onto the Microbit and get that running. They would then run that program to see what actually happens, and hopefully they would have got the fact that it is a happy face followed by a sad face, and that it holds for that time delay in between. Understanding the importance of having that delay, what happens if it doesn't, if it's not there, all these kind of things then fall into the investigate. And through that investigation is where they start thinking about, well, what, not actually changing anything, but looking at it and really trying to break it down. So it could be, well, what is the sleep line of code there? But it could be a debug. Now on this one here, it's got this program has an error. Can you find the error? And on here, if you can see the error, pop it in the chat. It's always nice to see if people can see it as well. But there is an error in that syntax there. And by looking at that error, they are starting to understand the syntax further. They are going to start thinking about how they need to write it. Absolutely, Bianca. No capital letters on happy and sad. And that is something that's really key in using this, that it has to be in capitals. So by pulling that out, they're investigating it. And then in the modify, they can go in and actually fix it. So again, I've got that set up here. So what they've got there is they can then open that up and actually go in and change that. So they're actually starting to modify the program to get that to work. And then they would then connect it up and download it to actually test that out. So by modifying it, they're then starting to understand it even further before they actually go into actually making something of their own. And then they could obviously move into say, right, well, can you come up with a sequence of images of your own and and use some of the different ones that are there? Again, building it up slowly to help them to understand what each line of code does. Another option is using lots of different things, like Parsons problems are one option that is a really good one to do. If you've not heard of that, it's a way of kind of giving them the building blocks to be able to then create the program. So it could be that, like this one at the top right, which I'll show in clearer in a second, is where I've actually commented out all of the lines of code at the top, not in the right sequence, and I've given them the start of the program down the bottom for them to then pop that, work out which lines of code go where, against a description of what I want the program to do. So they would need to uncomment by taking out the hashtag and then cut and paste in the lines of code and move them into the right sequence. It could be, again, down this one here on the right is that, again, I've got 3 options at the top that are commented out using hashtags. And then I've put hashtags into the main code where they need to put those individual bits of code in to help them to understand what goes where, and actually build up the program themselves. So I'm not throwing them in the deep end and saying, I want you to write a program that's going to do this, do X, Y, and Z. I'm giving them the building blocks to help build up that program so that they're getting the knowledge there. Same again on this one in the middle. Is you can add the code to display. Can you add the code to display a ghost? So I've got that there. And all I've done is commented out one area, but I haven't given them the building blocks this time. I've said, this is where you've got to pop the code. Can you go and pop them in there? So again, it's building it up depending on the level that you've got them at. Obviously, I wouldn't throw them straight into writing the code. I would have given them the building blocks first. But for those that are obviously moving on, we can start to look at that there. And one of the things that you can do, if I just go back onto my view over here, is this, here we go, is the example there with actually all of these lines of code here are commented out and can be popped down here by just copying and pasting. So I can just cut that out, pop that in wherever I want it to be. I'll pop it there for now. And I've got that now added in as a bit of code, and I can move that around. Using commenting to add the description is really useful. Now I've got this within Microbit Classroom because I can set that up then as individual tasks that I can then use within the classroom. I could, on Python editor, save the file by just downloading the Python script that I can then save and share out with students. or the hex file, whichever way around you want to do it, and then they can open it and use it that way. But Microbit Classroom allows me to set that up and actually have it ready to give to a student. So I can set up my classroom here, and I can share my dashboard with students for them to go on and actually be able to see what they're doing as they're working through it. If you haven't seen Microbit Classroom before, it is a great extra tool. And by going on, I'm just going to join this classroom here, purple mouse car gift. And I just purple mouse car. It always tests my memory when I have to do this one really quickly. I'm hoping this hasn't needed the need to be refreshed. So we've got caps lock on. There we go. So at the moment I can't see anything, but now as the teacher, I can go back on here. I can see that I am logged in. I can go on to editor. I can share my code with students. I can see which students are up, so I can differentiate, having different classrooms if I need to. And I've sent that out. And now I've got, as a student, I've got that available and I can start working on that. But the great thing that comes with that is I can actually go on as a teacher and look at the student code and see how they're working on it and see if they're making mistakes. You answer questions, support them, and guide them through that area. So using Classroom is a really great tool to be able to help them with that transition, because I can see what they're working on, as well as them working on the same problems or differentiating it across the classroom with different tasks to do. Microbit Classroom itself is really easy to set up. You've got it's classroom.microbit.org, and all I need to do is go in and set the name of the classroom. I can set it as Makecode or Python. Makecode obviously has the simulator in there, but you can't switch the view to Python in the classroom. It is purely block-based on there. Or I can go on to Python. And then that's where I get the editor. And it gives you, it always opens with the same default program. So it's a good starting point. But even on that one, I could put you can't add instructions on here. So adding in using commenting is a really good way of actually adding the instructions so the students have it in front of them. Can you change the image displayed? And then I can share that with students by using the dashboard there. The only thing to remember is that if you download, because I can save that classroom quite easily by downloading it and then reopening it, the dashboard information changes every time you open it. So something to remember there. Now I have on here, this is all the videos that I have got on how to use Classroom, but there's that Microbit Get Started cheat style sheet, I've called it. And all it is a document there, if you can see it, hopefully, if I just zoom in. Oh, that's a bit, there we go. So all I've got is I've put it all on a document of what can you change. So I can change the word happy here to any one of those there. So it's giving you all of the images that are stored at the moment within there to use. You've got little snippets of code all straight from the Microbit website of their examples of how to use it. I've just kind of put it all into one place. And then again, what can you change within the music, how to do the brightness, the speaker, and I have made it clear which ones are version 2 on there that are linked with that side of things. So it's a nice one to get them started on there with using that in their environment. So that is on there. I have got a little daft little sock puppet that I did with the Microbit on there, as well as some bits with extra resources that I use, like the robots and stuff, and a bit of a board game that uses up as well that can be used and build across. So I think, yeah, so I've gone through it. Fill in the gaps. You've got that, reorganize the correct sequence, start of code to build on, debug tasks. So again, you could literally just set up a program that's not working and ask them to try and find the errors and fix it for you. And all that's there to actually help them. And all these steps will help them understand the code before they actually jump into creating their own programs. And I think I've done that within time on that. Have I gone too fast, or am I all right on time? But please ask any questions. Is there anything else that I've missed? Anything that I can help on? please ask away. I think I might have got a bit fast on one of those bits. So if there's something else you'd like me to show, please ask.